If you think about the distance formula that I gave you yesterday, you have used the distance formula for a long time in your math classes. The distance formula that I provided you yesterday in 3 dimensions is very similar to the distance formula in 2 dimensions. It just adds that extra component of the z, right? So I do the difference of the z squared. So does anybody remember the midpoint formula? How do you find a midpoint between 2 points, x and y? See it?
x1 plus y, so x1 plus x2 over 2 plus y2 plus, but y1 plus y2 over 2.
Yeah, you basically you're adding up the x's and dividing by 2, and then you add up the y's and divide by 2. It's basically like taking the average of the x's and the average of the y's. So the only thing that we're going to add to the midpoint formula today is, in addition to doing the average of the x's and the average of the y's, we also have to do the average of the z's. So on the next slide, I'm going to say the midpoint between 2 points x sub 1, y sub 1, z sub 1, and x sub 2, y sub 2, z sub 2 is, and we're just going to write out that piece. I'm going to write it as like an ordered triple, so I'm going to have a parenthesis, and sometimes we label the midpoint as like capital M point, and so I'm going to say M equals, and I'm going to do x sub 1 plus x sub 2 divided by 2, y sub 1 plus y sub 2 divided by 2, and then only adding z sub 1 plus z sub 2 divided by 2. Anybody else? Have you all seen it? You guys are passing notes? Give me that note. Then juicy gossips pass this to you guys are just being okay. I thought that was weird, all this. Oh, I love juicy gossip. You're gonna have to do better than that. Okay, so really the same thing that Stephen gave us, but just with the added C. Okay. So here's an example real quick. I don't think that these are going to be challenging. Sometimes you might encounter like a midpoint where it adds up, when you add your x and your y, it comes out to an odd number. That just means you can either leave it as a fraction or you're going to have a 0.5. Okay, so nothing too crazy. We're going to find the midpoint joining the line segment 2, negative 2, 4, and 1, 3, 6. So I am going to show my work so that if I look back at my notes, I can see what the heck I was doing. I'm going to start with my x coordinates 2 and 1, and I'm going to add them up, 2 plus 1 over 2, comma, and I'm going to do my y coordinates, negative 2 plus 3 over 2, and finally my z's, 4 and 6, comma, 4 plus 6 over 2. I would like you to simplify that, and so you come up with something like 3 halves, 1 half, and then this would be 10 halves, which is 5. I've got a midpoint. If we plotted those 3 points in space, so if you use one of your coordinate systems that I gave you yesterday and plotted those 3 points, you should see that it looks like that midpoint is in between those 2 points in space. Okay, so that should seem reasonable to you. Any questions about midpoint formula? Okay, then we will move on and we are going to discuss the equation of a sphere. Okay. Basically, the equation of the sphere in 3 dimensions is much like the equation of a circle in 2 dimensions. So in the equation of a sphere, you're going to have a center point. Normally in 2 dimensions, the center point is just hk for a circle. Now it's going to be hkj. And you still have a radius. And we'll use r for our radius like we use for our circle in 2 dimensions. A sphere, by definition, would be a three-dimensional object in which the set of all the points x, y, and z that satisfy the equation are a distance, or are such that the distance between the center point hkj and all the points x, y, z happen to be the same, r. So you get that nice, smooth, spherical object. And this is just an image. This is from your textbook, so you could look in section 11.1, and you could see this same picture. You can see the center of the sphere. So imagine like like a little toy ball that you used to play with. Okay? Inside is the center HKJ, and then in order for it to be perfectly round, the distance to all the points on the surface of the ball would have to be the same. Would be that r value, radius. So before I go to the next slide, I guess I'm curious, do you remember the equation of a circle? Have a quick discussion just with the people around you. Does anybody remember the equation of a circle? See if it can spark anything. Okay, chat really quickly. Anybody come up with the equation of a circle? From probably geometry. I mean, we've talked about it. We talked about it in conic sections a little bit, briefly. Stephen, what did you guys say for the equation of a circle?
X minus h squared plus y minus k squared equals r squared.
Yeah, x minus h squared plus y minus k squared equals r squared. So then you immediately knew where the center of your circle was. And then if you had r squared, you could figure out what the radius is. So what do you think we're going to add to the equation of a sphere? Z minus j squared. Okay. So the equation of a sphere, I'll write it over here, is going to be something like x minus h squared, same as a circle, plus y minus k squared, same as a circle, plus z minus j squared, that's new, equals r squared. Okay, so you're just really always adding that third dimension, that z-axis. Okay, that's now at play. When we introduce the z-axis, in the center point, we introduce the coordinate j. Okay, so that goes along with z. And if you have an equation of a sphere in this form, then it would be really easy for you to pick out the center point of the sphere, hkj. Remember that when you take all of those numbers out of the equation, they would look like the opposites because they have minus signs in front of them. And then you could easily spot the radius for the sphere. Remember that whatever number it is equal to on the other side, you have to take the square root of it to get the radius. Okay, so that's actually equal to r squared. So here's an example for working with a sphere. We're going to find the center and radius of the sphere given by this equation. X squared plus y squared plus z squared plus 4x minus 2y plus az plus 10. Equals 0. If we want to find the center and the radius, the easiest way to do that is to have it in what we would describe like the standard form for the sphere, which is what we had on that previous slide, x minus h squared, y minus k squared, z minus j squared. What do you think we might do to make it look like that? Actually, complete the square. It's just like our work with conics, right? We wanted to make the ellipse look like standard form, we would have to group the x squared and y squared with their other terms, so with x for x squared and with y for y squared, and then complete the square. So we're going to do the same thing here. I'm going to group together the x's. So I'm going to put x squared plus 4x. I'm going to leave a little space to complete my square right there. And then I'm going to do plus y squared minus 2y. I'm going to leave some space to complete my square. And then I'm going to do plus z squared plus 8z. Leave a little space to complete my square. And what would I do with this plus 10? Move it over to the other side. So I'm also going to subtract 10 from both sides and then say equals negative 10. Okay, I'm going to be adding things to that side where the negative 10 is as I complete the square because I got to keep my equation balanced. So most likely that's not going to end up to be a negative, and r squared shouldn't be negative. So then it will come out to be some positive number, and I'll be looking at the radius for the sphere. Okay, so we've got to complete the square. What value will complete the square for x squared plus 4x?
4.
4. You're going to take half of 4, which is 2, and then square it. So we're going to put a plus 4. If we put a plus 4 on the left, then we have to do plus 4 on the right. Think to yourself, what value is going to complete the square for y squared minus 2y? Y squared minus 2y. Take half of negative 2, and then square it. What value completes the square there, Joe? Plus 1. A lot of times on the conics test and on the final, I had a lot of people who completed the square right here and got 4. Don't know why, but it was a really common mistake for the, if you had plus 2y or negative 2y, a lot of people put 4 there. So watch out for that one. And then think about that last one, z squared. What will complete the square for z squared? Plus 8z. Haley? 16. Yeah. Half of 8 is 4. Square it, you'll get 16. So we're going to add 16 on the other side. So then you can do the work, and each of these perfect square trinomials are going to simplify. So x plus 4x plus 4 is really x plus 2 times x plus 2, or x plus 2 squared. Okay. Plus y minus 1 squared, plus z plus 4 squared. And then negative 10 plus 4 is negative 6, plus 1 is negative 5, plus 16 is 11. So here's my equation of a sphere in standard form, and then it's very easy for me to identify my center and my radius. When I pull out the center, the h value will be negative 2, positive 1, negative 4. And then remember that this 11, that's my r squared. So r squared equals 11. I would have to take the square root of both sides. Always I should treat this like a radical. In any other scenario, simplify the radical. Square root of 11 doesn't simplify, so I can just say my radius is square root 11. Now, I did kind of take for granted and make some assumption that we're all comfortable really with completing the square and then rewriting that as the square of a binomial from chapter 10a. If you at this moment are thinking, oh my gosh, I didn't really learn that, I just kind of like had it and then spit it out and then left it, okay, spend a little bit of time with it, make sure that you feel comfortable with it. Any questions there? Okay. We can also do other things like find the standard equation of a sphere with a center at 1, 5, negative 2, and a radius of 4. That's going to be really easy, right? Plug those things for h, k, j, and r. And so you're using the standard form equation. And you have H, K, and J listed. You also have your R, so you would just be plugging those things in. X minus 1 squared plus y minus 5 squared. Oops, writing a circle there. Plus z plus 2 squared equals 16. So that one's really easy. If you get the center and the radius, you just plug them in. There is a question here which asks, does the sphere intersect the xy plane? So now you've got to think about this visually. Does the sphere intersect the xy plane? I'll give you a moment to think about it on your own. And then see if you can have a quick discussion with the people around you. Do you think that this sphere would intersect the xy plane? Can you explain your reasoning as to why or why not? And so share with each other what you're thinking about right there. See what you got. Take it. You need a pass control? I guess he doesn't. What do we think? Yay or nay?
Yay.
Yay? Yes? Can someone explain why? Or how they reason that out? Ashley.
I said because the radius is 4 and the center's only moved down 2, so it would come up above xy.
Yeah. I mean, in order for you to intersect the xy plane, you're really thinking about z's at that point, aren't you? Like, how far away from the xy plane is your sphere, and that to move it away from the xy plane, you're moving it with z. You're adding so that you're moving it up, putting it in space, or you're subtracting and moving it down in space. And so when you think about this particular sphere, because the z coordinate or the j coordinate of your center is only at -2, and the radius is 4, it's going to go 4 above, below, around, in all directions to create the outer piece of the sphere. And so that's definitely going to cross the xy axis. Because if you go up 2, then you're at the xy axis. Okay, so you're thinking about it in space, and if you want to know if it's going to intersect a particular plane, you're basically looking at the other coordinate, right? So if you want to know if it's intersecting xy, look at z in the radius. If you want to know if it's intersecting the yz plane, then you would look at the x in the radius. Good. Thank you for sharing your reasoning. Okay, we already did our quiz trade, so you are now working on your homework assignment. You have about 15, a little over 15 minutes. Okay, so get started. You saw in our notes, questions don't take very long, so you can get some of it done, maybe perhaps all of it. 45 to 69 odds really isn't that much. Now work on your assignment, don't pass notes.
Yeah.